All right, so this is Algebra 2 Honors, and this is Intro to 6.1. And you have some worksheets with a few problems on each of them. And we're going to start with exponential growth and decay functions. And that the form of the function is y equals ab to the x. And assuming that a is positive, then we look at the value of b. And if it's greater than 1, you've got growth. But if b is between 0 and 1, then you have decay. And the growth and decay functions look like this. That would be exponential growth. And for exponential decay, it looks something like this. And we get what we call a horizontal asymptote. And it is the x-axis. And so that x-axis, the function follows and gets closer and closer and closer to that horizontal asymptote. It never touches it, never crosses it, but technically gets closer and closer and closer to it. So an asymptote is something that that function is following and getting closer to. It's a value that it's approaching. All right, so anyway, I'm going to want you to tell whether it's growth or decay, graph it, show a table of values, identify y-intercept, horizontal asymptote, domain, and range. So on this first one, it's of that form a b to the x. So it's an exponential function, and the base is between 0 and 1, so it's going to be exponential decay. And then create a table of values. And I typically start with -2, -1, 0, 1, and 2. Occasionally, those don't get me the form that I'm looking for. It doesn't go far enough to show me that it's really an exponential growth or a decay. So sometimes you might have to use, say, -10, -5, 0, 5, and 10 to get it so that it's starting to actually get a nice curve to it. It just depends on the value of the base and the value of a. But I start by trying -2 to 2. And then just plug them in and evaluate. So we have 2 1/3 to the -2nd, which is 2 times 3 squared, and 2 times 9 is 18. And then 2 times 1/3 to the -1, which is 2 times, you flip it, so it's 2 times 3, and you have 6. And then 2 times 1/3 to the 0th, well, anything to the 0th is just 1, and you get 2. And then 2 times 1/3 to the 1st is 2/3. And 2 times 1/3 squared is 2 times 1/9, so it's 2/9. And -218 is off the graph, but I don't have to plot it. The other points plot out and still show a nice decay function. So -1, we're going to be up at 6, at 0, we're at 2. And at 1, we're at 2/3. And at 2, we're at 2/9. And by the time you'd hit -2, you'd be way up at 18. So it's coming from that height of 18, 1 over. And it's coming down. And the line's going to get closer and closer to the x-axis, but never touch it and never reach it. And so the best you can kind of do is just get really close and then just kind of run it parallel to the x-axis and put an arrow on it. You don't want it to pull away like it's going back up, because it's not. It's getting closer and closer to the x-axis. Never touches it, never crosses it. And then, so then I want the y-intercept, and that's when x is 0, and at 0 the y value is 2. The horizontal asymptote, we're just going to abbreviate HA. It is an equation of a line. It is y equals 0. It is the x-axis. And the domain, all reals. But the range is 0 to infinity, not including the 0, because it never reaches the x-axis. On the next one, it's that form y equals ab to the x, so it's an exponential function. B is greater than 1, so it's exponential growth. It is exponential growth. We're going to do a table of values. Again, I'm going to just start with -2 to +2 for x. And see what it looks like. And I get 3 times 2 to the -2nd, and that's 1 over 2 squared is 1/4. You get 3/4. And 3 times 2 to the -1, that means 3 times 1/2, which is 3/2. 3 times 2 to the 0th, which is 3 times 1 or 3. 3 times 2 to the 1st is 6, and 3 times 2 squared is 12. That's going to be enough to get a nice curve to it, so I don't need to go further to the left or right. So at -2, I'm at 3/4. At -1, I'm at 1.5. At 0, I am at 3. At 1, I'm at 6. And then I'm off the graph before I hit 2. So it's and then it's just going to get closer and closer to the x-axis. So kind of end with it looking like it's parallel to it, and that's is about as good as we're going to get. And then the y-intercept is when x is 0, it's 3. The horizontal asymptote is at y equals 0. There's no shift up or down. Just, if you had y equals 3, 2 to the x plus 5, then it's going to shift everything up 5, and your horizontal asymptote would be y equals 5. Just a, what if. Your domain, all reals. And the range, 0 to infinity. All right, so your first worksheet in your homework will be graphs and doing what we just did in this example. The second worksheet is going to follow what we're coming up on next. So we have an exponential growth and decay model. And it's in the form of an exponential function, but they write the base as 1 plus r if it is greater than 1. Oops. And they write the base as 1 minus r if it's between 0 and 1. And the other thing is it just is to the t. Thinking over time, t for time. A is your initial amount. R is the percent increase or decrease written as a decimal. The value of 1 plus R is a growth factor, and when it's between 0 and 1, it's a decay factor. Now, they want you to find the percent rate of change, which is find the value of R and change it to a percent. But for the growth model, the time needs to be a 1t. And here they give it as t over 12 and 2t. So we're going to make use of structure and change that around, and that's where you're going to need your calculator. We are going to take 1.25 to the 1/12th, and that puts t outside, which is what we need to move towards, is it's just to a 1t. So take your calculator and take 1.25 to the 1/12th and go to at least 4 decimal places. So 1.25 raised to the 1/12th. It's not exactly 1.0188, is it? Or did it come up, huh? It's rounded, isn't it? That's rounded, correct? So what I should do is change that to approximately equal to. So because this value is bigger than 1, it's going to be growth. And in the growth model, we separate it out and write it as 1 plus, and then we'll figure out what the rate is. So we're going to write it as 1 plus the 0.0188. And again, the reason for changing is because in the growth model, it just needs to be the 1t. And so when it's written like this, our initial amount's 120, and this is my percent increase as a decimal. So change it to a percent, you multiply by 100, and R is 1.88%, and you need to state whether it's increase or decrease. It's an increase. And we need to do the same with the next problem. Make use of structure, and to get it to be a 1t on the outside, we're going to move the squaring in and just have a 1t outside. So you need to square 0.85 and go to at least 4 decimal places. That's probably exactly 0.7225, is it? Yeah, so I don't need squiggle equals. Yep, there we go. So formal, I should say. We don't need approximately equal to. It's exactly that. Now it would be very easy to go, oh, well, that's between 0 and 1, so it's a decay. But that is not your decay rate. It is not 72.25%. That's what remains after each time unit. You need to change that to 1 minus R, and so it is the 1 minus R that needs to be the 0.7225. That's what I need in there for it to have the exponential decay model format. So this value right here needs to become this. And so I'm setting 1 minus R equal to it, and I'm solving for R. And so that means subtract 0.7225 from 1, and that will give me R. And that comes out to 0.2775. So I need to replace this 0.7225 with what is equal to it, and what is equal to it is 1 minus that 0.2775. And now this follows this format. So this is your percent decrease as a decimal. So as a percent, you move the decimal 2 places to the right, you are multiplying by 100. And you need to say that that is a decrease. Now, so that second page of assignments is going to be like this. And then I don't have examples for the page 3 because page 3 is something you already have done. And there are examples on page 3 for that. So on page 3, you're finding zeros of all these functions. It says skip 2 and 10. I've already eliminated. They're not on there. And so you're finding zeros. So write the original. You set it equal to 0. And there's examples up here. For in this case, you don't have an x, so solve by square roots. Move it over, you get plus or minus. Set it equal to 0, factors. So each of the factors, you get 2 solutions. Set this equal to 0. It doesn't factor. And you can find that out by finding the value of the discriminant, that it's not going to factor. And it actually comes out as complex. So use those to help and find the zeros of those functions. And that's it for the lesson.